In this video, I will demonstrate a bidirectional integration between an ELN and an instrument control software. First, I will run us through the experience from a scientific end user persona, and afterwards I will guide you through the similar workflow and illustrate how this was achieved using the Tetra Data platform. So let's dive in. In our fermentation lab, we have been performing a small-scale fermentation experiment. In an Amber 250, we have been simulating various growth conditions and measuring, amongst others, total and viable cell count over time. Every time point was a different experiment in my benchling notebook. In this experiment, we are measuring some samples 72 hours after inoculation. Out of the different fermenters, 15 samples were created for the various conditions. Total and viable cell count were measured on the CDEX high-res. The sample information was sent to the instrument control software, SDC, and after the measurement, the results were pushed into the experiment without any manual interaction. The link to the raw data files are now part of the experiment. Further down, a Spotfire dashboard is showing the growth curve of the different conditions in my Amber 250. The measurements of the other time points are part of different experiments in my ELN. The dashboard is populated from the harmonized data in the Tetra Data platform. One of the values of the Tetra Data platform is that the data, once ingested, is engineered and harmonized to use downstream by various sources, including your ELN or data analytics solutions. So let's create a new experiment. I will create a new entry in the benchling notebook. In the experiment, the scientists can perform their experimental write-up, including hypotheses and procedures that were followed. The scientist in this case will also create a new set of samples for the next measurement. For sake of the demonstration, we will create 3 new samples in this experiment. Once the samples are created, the scientist will also trigger a new run for the CDEX high-res. The samples are added to the run and the required metadata like device number and sample type are added. By submitting the run, the samples are now sent to the instrument control software. The scientist walks over to the instrument and sees his samples in the queue. The samples are being measured and the results will be pushed back to the specific experiment for which the run was triggered. By refreshing the experiment, the new data becomes visible, including the link to the location of the raw data. The results are now also harmonized, and the new data points will become available in our dashboard. As you might have noticed, you've not seen the Tetra Data platform yet. I've only been showcasing the ELN and the instrument control software, meaning that the implementation of the Tetra Data platform for the scientific end user should be non-invasive. Let's switch now to the Tetra Data platform. Before we focus on the workflow, let's first have a look at the hamburger menu in the platform. The first item is agents, which are the various ways in how to connect to different data sources, which could be through files, SDKs, or APIs. Here are some examples. For instance, the agent for SDC. Our ambition is to develop productized integrations between the various data generators and data consumers. After this sidestep, let's come back to our example. Once the run was submitted and the triggered pipeline is completed, I can open up the pipeline and review its configuration. In this screen, the trigger, the protocol that's executed, as well as whether any notifications should be sent are configured. Descriptive information about the run, including the sample identifier, is pulled from the ELN and pushed towards SDC. I can open up the details of this specific pipeline to showcase the content that's being pushed to SDC. In SDC, that sample ID is now added to our queue for the actual measurement. Once the measurement in the CDEX high-res has been completed, a new file has appeared in our Tetra Data platform. That file has been decorated with additional metadata coming from that SDC agent. Defining which metadata needs to be added is determined by your organization. It can be fixed values, but can also be values originating from the file path or content captured within the file. When opening the file page, we can see all of the content. The file can be downloaded or a new version can be uploaded. The Tetra Data Platform is also 21 CFR Part 11 compliant ready. A full audit trail is available, so any modification is captured by the Tetra Data Platform. There is full traceability of each of the files that has been ingested by the Tetra Data Platform. Each of the pipeline documents, the files that were used as input, and the file that was generated as an output. This specific pipeline also converted the raw data from the CDAC high-res into our intermediate data schema, or IDS. By harmonizing the data into this open data format gives your organization the capability to compare results across various instruments and techniques, and use that data downstream by, for instance, your ELN and/or preferred analytics solution. The final pipeline in this workflow pushes the harmonized data for the specific sample back into the experiment in BenchLink, and added a new measurement in our Spotfire dashboard. This concludes our round-trip workflow between BenchLink and SDC. I hope you find this video useful. To summarize, in this video I've illustrated how scientists save time by reducing manual steps in collecting and archiving data. IT can leverage the productized integrations of the Tetra Data Platform and is not on the hook for maintaining those integrations. Data scientists can now use the harmonized data to find and utilize that for their further data analysis pipelines. In case you would like to receive more information, feel free to go to www.tetrascience.com to find all of the documentation available on our platform, or get in contact with a representative in your local area.